Good day everyone, I'm Emerlyn Judd D. Mamales and I'm with Riz Maria Mactal and we're going to discuss the radiation pattern and antenna design using MATLAB. Next please. The concept of patch antennas evolved from the use of printed circuit boards, not just for circuit components and transmission cables, but also for an electrical system's radiating components. So the basic structure of a microstrip patch antenna consists of a ground plane, a thin dielectric substrate, and a patch. A patch can be in a rectangle, disc, ring, or triangle shape. Next. The rectangle, the circle, the equitriangle, and the annular ring are common shapes of patch antennas. So these are the advantages of microstrip patch antenna. It is planar, which can also be made conformal to a shaped surface. It is low profile, it is rugged, printed circuit technology, or it can be used by printed or it can be produced by printed circuit technology, and it can be integrated with circuit elements, and it can also be designed for dual or multi-frequency operations. Next. Given the advantages, there is also the disadvantages. So the disadvantages of a microstrip patch antenna is it has a small impedance bandwidth, often less than 5%. It is a microstrip antenna and it can only take a little amount of RF power or radio frequency power, and it can have ohmic loss greater than arrays of other types of antennas of equal size of the aperture. Next.
So here's the MATLAB code that we imported after we created our antenna design. For the array, the simulation was made using the Antenna Array Designer in Antenna Toolbox of MATLAB. The students designed and created patch antenna arrays. In the array gallery, the students chose linear and circular patch for antenna gallery. The number of elements is 3 and 5 GHz for its design frequency. The results will be shown through 3D pattern, azimuth pattern, elevation pattern, and S parameters. So for the array, as you can see, we used a circular microstrip patch antenna with an element spacing of 0.036275 meters. And for its radius, it is 0.017688 meters and has a height 0.00192, and both of its ground plane length and width is 0.059958 meters. For the layout 3D, as you can see on the screen, we use 3 elements in the linear array. For the 3D pattern, we used 5 GHz for its frequency, and the output has a maximum value of 12.4 dBi and has a minimum value of negative 37.2 dBi. Additionally, the intensity of the radiation, as you can see, is upwards. For the azimuth pattern, it shows the radiation pattern of the antenna horizontally or in the XY plane and has a greater intensity in the 90 and 270 degrees. Also, it has a peak value of negative 2.717 dB. For the elevation, as you can see, it elevates to 90 degrees, which radiates upwards and has a peak value of 12.35 dB. And lastly, for the S parameters, in this slide, this shows the value of the S parameters in the diagram. It is all below 0, which means that it can transmit or radiate information. So thank you for listening.